we covered everything we needed. So Java, JPA data modeling. We looked at users first. Let's look at inheritance, which is pretty interesting. For instance, here we have user, faculty, and student. Faculty and student are inheriting from user, as well as the widgets, right? The widgets also inherit from the base widget. So we have the base user. We have user as a repository, the table. Sometimes you need to do queries that are not the ones that are supported by the repository. The repository supports all the major types of queries: find all, find by ID, delete, count. But sometimes you need to retrieve things differently, right? For instance, if you're logging in or registering, you want to check to see if the username is taken, for instance, right? So you can, in your repository, you can declare. Notice that it's an interface, right? You don't implement anything. You don't implement anything. Instead, you declare the signature of how you want to use your query. For instance, if you want to retrieve a username by username, by a user by username, for instance, right? Meaning the attribute would be username, and this is how you want to use it: find user by username. So we know we implemented find something by ID, find all. This one's find by some criteria. Right? So first you declare it, then you declare the parameter that you're going to use. You're going to declare it as a parameter, giving it a name. It's a named parameter. You can then use that name as part of a declared query of what is the query you want it to use to retrieve something from a database. This is the query I want you to use. Right? Select from where user.username equal username. Notice the placeholder. Notice the colon here. So this is a parameter that is being generated. It's being fed from the value of the parameter that you pass in, is mapped by name to the placeholder. Also notice here that the select statement is not entirely SQL. Okay, it looks very much like SQL, but it's a little bit higher level than SQL. Right? It's an object-oriented SQL. Right? That select user, that's an object instance user. From user, that user, notice it's an uppercase user, meaning that's a class user, not the table user. Right? That's a class user. So you're declaring a variable user of type user. And then you're referring to it here as an object. Because you're not specifying any field, this is interpreted as I want all the fields. And then the where clause. This looks very much like a where clause, right? So you have a table dot field. It's not that. It's an object dot property of that object instance, equal then the placeholder. Here's another one. I want to retrieve user by credentials, maybe for login, when you're logging in. Retrieve for me a user by credentials. I'm going to pass you a username and password. Retrieve for me the user whose username and password match. Okay, and this is returning as a list. It doesn't have to be a list. It could be a single user, right, to see if the user exists. So for instance, here's an example on retrieving user by ID. We did this already, right? This is a find widget by ID or topic by ID. We did this already, right? Here's find all. Right? That's easy, right? Just find all, .find all. Here's the one. It's a little more interesting. So last week we talked about in your requests, right? You can pass in path parameters, which we've been using path variables, right? But you can also pass query strings, right? And so the question might be, when do you use one or the other? If we want to stay within the REST naming convention, if here we would be retrieving find all users, that URL it matches, right? / find all users, for / API / user. That retrieves all the users. But in what you would use query strings to filter something that would otherwise be an entire really long data set, right? So the query strings, you would provide the values of predicates that you would use, of parameters that you would use for a predicate. For instance, in this case, find all users. If you don't pass any query strings, notice that the request parameter has an optional, notice required false, meaning you don't have to pass in the query string. If you pass a username query string, then we can use it. We can use it here. So if it's not null, meaning if it's present, if there is a username, meaning if your query ends, if your HTML, if your HTTP query ends with $username, right? So if you have a / API / user, and then you have a query string, username, so username equal Alice, right? Then the variable username, uname here, would be Alice. Right, so if I have a username, here we're using the user repository find user by username. See that? Right? So I'm using it like a filter, like a query, like a predicate. Otherwise, if I don't pass the username, I'm going to return what I normally would have returned. I return all the users. Yes? See that? We can extend this a little bit further. We can extend this a little bit further. I could pass it a second request parameter with a password. Right? And then I can use if I pass a username, then it retrieves the users who have that username. Ideally, it's unique, so it'd be just one. If I pass in username and password, then it would find by credentials. Is there a username with that password? Okay, so this could be two if statements. It could be if I have a username, retrieve the username. Else if I have both username and password are both null, not null, I can then find user repository dot find user by credentials, username comma password. Yes? Right. Otherwise, if I don't have either, just retrieve all of them. So that's a very common design pattern for if you're having queries. Update, posting. If you're creating a new user, like register, this would be register, right? So in register, right now, what we do is just that we're adding it to an array. Yes? To a local array. Instead, we want to save it to a database. So to save it to a database, we use the repository. And the repository, just like it has .findAll, .findById, .delete, .count, it has a .save. .save will do an insert into a database. It will take your user object or your widget or whatever, right? And it'll store it in the database. It'll do an insert. Okay. If you're doing an update, meaning you're modifying an object that already exists in the database, right? The RESTful, as we saw last week, the RESTful API would be /API/ the entity, whether it's user, topic, widget, whatever it is, / the ID of the existing record. Right? We would parse it from the URL. We know how to do that. Also, here's the brand new instance. Right? So to update the database, what you need to do is first find the record in the database. Find it. Does it even exist in the database? It should be there. Presumably, we're updating a record that already exists. So first, we need to retrieve it from the database. So we use the find one. Actually, that's an older API. So this is find by ID. Okay, and let me. And this is .get. Okay. All right, the new ID, the new API is like this. So find by ID, you retrieve it, and then you update the fields you want. You have your logic. Maybe you don't allow folks changing their username, or maybe you don't allow them to change in some fields. So your logic of updating will be different, right? Ideally, you won't change the primary key. That you don't change. You should not change the primary key. Once you've modified your object, now your object has your new values. You can save it back into the database using the same .save in the repository. The .save is smart enough to know whether this is an insert, if it's a brand new object, or it's an update, if it's an existing object. Make sense? So that will be an update. That second .save is an update, not an insert. All right? Delete, it's easier, right? You just dot delete, at delete mapping, right? So that's your URL you worked on last week, and here we are mapping the user, retrieving the user ID from the path, and just the repository has a dedicated delete by ID function. That's easy, right? You just say delete by ID, and poof, it's gone. Make sense? All right, let's look at faculty. The faculty has several one-to-many relationships, which we already covered, of topics and widgets. Yes, so we have, for instance, we have a faculty. Here we have an extends user. Extends user, right? We do have that. Notice what it's doing when we say extends user. What it'll do, which is pretty cool, it'll take the original user table. It'll take the original user table. Notice that the faculty only has an office and a tenure. It has those two fields. See that? Obviously, the user table doesn't. The user class doesn't have those, right? The faculty is extending the user with these two new fields. Notice what it's doing. It's that it's going to alter the original user table. It's going to alter the original user table. It's going to add the two fields from the faculty. See that? Right. And it'll add an additional meta field to be able to distinguish whether this record is a plain old user record or is it a faculty record. Right. If it's a user record, this will say user, and it'll have values for these fields. If it's a faculty record, it'll have these values, plus it'll have values for these other two fields. Make sense? So this is called a denormalized strategy that can support inheritance. Right? There are two additional strategies. Right? For the assignment, you're only asked to do the default behavior, which is the denormalized strategy. All the inheritance classes, all the derived classes have their own dedicated repository. Right? So for instance, if you have YouTube or you have all these other widgets, each one will have to have its own dedicated repository. So you can interact individually with each type of widget. Right? Even though they inherit from a base widget. So here's faculty, faculty server to retrieve all the faculty. We inserted a faculty just to display. This retrieves all the faculty, Tim Berners-Lee and Ada Lovelace. The student entity also inherits from user, right? So extends user. When you generate the JPA will oh, I didn't show that. Oh, I didn't show that. Oh yeah, when the table is regenerated, right, it'll have everything, right? First name, last name, everything that is from the user table, plus the 2 fields from the faculty, plus the fields from the student table. Again, denormalized. Okay, so it has the fields from one of the the 2 derived classes. Also, the student repository will have its own. The student will have its own repository. It will have its own service. Okay, each entity will have its own repository and its own service for retrieve. These all retrieve all the students. Notice that this repository is smart enough to, obviously, even though it's the same table, if you ask for the students, you'll only get the students. If you ask for the faculty, you'll only get the faculty. Right? If you ask for the user, it'll retrieve all of them. Yes?
So we need to maintain the hierarchy in the repository as well?
The what?
The same inheritance hierarchy we should maintain in the repository as well, as in we have one base repository and then we extend from base.
In the table? No, the table is only one table.
No, so the table is one, but when we create repositories in JPA, should we have one base repository and then the user repository should extend from the base?
No. Well, you can do that, but you don't have to. It could be independently. Yep. You can just try. Okay. We insert a student, insert another student. We retrieve one-to-many. We talked about that, right? Courses. Faculty has many courses. Each course has many sections. So here's course. It has a reference to the faculty, right? The JSON ignore, right? There it is. Otherwise, it'll get into an infinite loop. Yes?
By default, is that an association or a composition when you have the
One-to-many, it's an aggregation.
you change it on those fields?
Yeah. Yes, you can. Yeah, you can have cascade all, cascade delete. You can configure what you want it to be. Right. So we have a course. We have a faculty. Faculty doesn't need JSON ignore here. So this is on the one side of a one-to-many relationship. A faculty has many courses, right? Just like topic has many widgets, has a one-to-many. Notice the map by. We looked at that already. From the course's point of view, we have the fields for the course plus a foreign key back to the author, right? Declared as a foreign key back to the author. Now the association between two one-to-many relationships, right? In a relational database, the association between 2 records that are participating in a one-to-many, the only thing you need to do is the child on the many side has to have the foreign key pointing to the parent side on the one side. Yes? That's all you really need to do. Now from Java, it's different. Right? Notice that in a relational database, that relationship between 2 records, it's bidirectional. In that you just need to join. You have to to navigate from one to the other. You just have to say where the foreign key of this one is equal to the primary key of the other, right? And that allows you to either select fields from one table or select fields from the other table. So you have access to both, right? So you can navigate from either side. Right? In Java, that's not explicit. Right? In Java, you can say I have the parent, and a parent might have list of children, but not necessarily that the child has references back to the parent, right? Or vice versa. The child can have references to the parent, but not vice versa, that the parent has references to the child. Yes? But because we want to support the same features that you have in relational databases, that you can navigate both ways, typically what we do to support that in Java, we have to explicitly provide setters and getters to go both ways. Right? That creates a problem. It creates a problem because it's redundant saying that, hey, topic, here's a new widget. That's kind of the same thing as saying that, hey, widget, here's your topic. Right? And from either side, you can initiate the relationship explicitly from either from the widget side or from the topic side. But it should not. Once you start that relationship from any side, right? It should be mirrored, right? It should be that if I say that this widget belongs to that topic, right? Then the topic should also know that, oh, well, yeah, I have a list of widgets. I need to add it to my list of widgets, and vice versa. If I add it to the topic should tell the widget that I am your topic. Right? It should go both ways. So you could initiate by either telling the faculty, hey, faculty, here's a new course that you've authored. So certainly you would say something like this: all the authored courses .add course. But this doesn't say anything about the course knowing about the faculty. Right? Here's only one side, right? It is the faculty knowing about the course. Yes? So we need to explicitly tell the other side, hey, course, did you know that I'm your author? You didn't know that? Right? Well, I am. Right? So it's, again, to establish the both pointing to each other, because in Java it's not explicit, right? Whereas in relational databases it's not implicit in Java, right? Whereas it's implicit in relational databases. Or you could have started from the other side, right? You could have said, course, hey course, this is your author. Here's your author. And there it is. This is this author, author. But we have to go a little further and say, hey author, did you know that I am a new book, I am a new course that you've authored? You didn't know that? Well, yes, I am. Right? Add me to your list of authored courses. You see that? Because we want to support navigating from both sides, which is, again, it's not implicit in Java, but it is in relational databases. So here's some testing. I'm trying it out. Creating new courses. So here's where, for instance, the mapping might say, I want to add a course to a faculty, and I could do it both ways. I can do it in any of two ways. I can either, well, in both cases, I need to go and fetch both records. I have to fetch the faculty, and I have to fetch the course. Presumably, these are two records that already exist in the database, right? But they're not related. They're not yet related. Yeah. So I find the faculty, I find the course. I can either say, course, here's your author. And what will that do? It'll say, author, here's your course. Right? It'll go both ways. Once I've told the course who the author is, I can use the course repository to save the course. Or I could have done it backwards. I could have said, hey, faculty, here's a new course. And then I could have used the faculty repository to save the faculty. Right? I could do one or the other. Yes?
So can we maintain this synchronization between the set and the child? So when we save, won't this be a new repository return that the copy would be out of sync? As in when we do course recording directory, so to save course,
Yep.
in that case it would return us a new entity, right?
Well, no. Either one you do, in the database, the only thing it'll do is it'll update the foreign key.
No, so it will update the foreign key, but the return type of the save API, it would return me a course which is different from the course that we saved. The two entities would be different, right? In the object.
Right. No. Here you would receive the latest course.
Right. So
The latest course.
the latest course would be out of sync with what you
Right. No. You would have to say course equal that to update it. Yeah. You have to say course to update. Yeah. That's a good point. These objects, when you retrieve them from the database, right? They are special objects. Okay, they're not. They have the names that you gave them, course and faculty, but actually, these instances of these objects are referred to as managed objects, right? Objects that the underlying framework is aware of and keeping track of. right? So that anything you do to them, like setting the author, changing the title, or anything like that, any modification you make to the objects, right, the framework is keeping track of what you changed, so that when it goes to save them to send an update to the database, right, it knows that you only touched these 2 fields out of 30. Right, so it knows which fields were changed. Okay? So what they do is that your setters and getters are actually rewritten in such a way that they're wrapped. So this object instance here, course, actually it's a wrapper object around your class that has the same name, so it compiles fine, right? But it intercepts all your setters. So whenever you do a dot set, it's their set. Right? So they keep track of, oh, this object is dirty. Right? It changed state. Okay? Then it calls your set. But before, it keeps track of of the life cycle of the object in memory, so that it knows when it does this dot save, it says, I know what changed. These 2 fields changed. So I know when I write my update, I only update those 2 fields. Right? So it's a fairly complex things going on underneath.
And also the author would have a set of courses, right?
Yes.
So once we save the courses, the course in that set would be detached, right? Because we already attached this new entity by doing the save. So won't these 2 copies be out of sync?
Yeah, you have to reassign them.
So after we perform save,
Yep.
we already have a course in the author set.
Yes.
Would have a set, it would have old course, not the new course written by the save.
Yeah, exactly. It would be a completely different one. So that would become a detached. Yeah.
So we need to remove that and we need to add this one.
Well, if you want to do this, yes. If you want to save it the other way around, yes, you would have to reattach it. Yeah. So you can't do, you can't do both. So let's use either, not both. Okay. Yep. Find author. Okay, one more. Many-to-many. So many-to-many is a little bit more involved. And this is when you, although I don't know, do we have many-to-many in our assignment? I forget. I don't think we do we? All right. Nevertheless, let me chat about it.